Probability distributions. A discrete random variable x has the probability distribution shown in the table. So that means discrete means it can only take certain values. We can see from the table, we can get a 1, 2, 3, or 4. And we've got the probability that x, the variable, takes the value x. So the probability that x equals x, that means the probability of getting each of the values. So the probability of getting a 1 is 0.2. We need to find the value of k, and all the probabilities have to add up to 1. The probabilities have to add up to 1 whole. So we've got 0.2, 0.1, and 0.3. That adds up to 0.6. So k has to be 0.4 for it to add up to 1. Here's a question for you to try. See if you can answer the question. So again, a discrete random variable x has the probability distribution shown in the table, and we can see the probability of 1, 2, 3, and 4, they're the same. So it's called a uniform distribution. It's a uniform distribution. And the probabilities are all the same, so they must all be a quarter, or 0.25. Here's another question. The random variable x has a probability function. So the probability that x equals x is k over x, and x can take the values 1, 2, 3, and 4. I'm going to draw my distribution. So I'm going to have x, and the probability that x takes the value x, we're going to have 1, 2, 3, and 4. And then our probabilities are going to be k over 1, which is just k over 2, k over 3, and k over 4. We need to find the value of k. And we know the probabilities have to add up to 1. K plus k over 2 plus k over 3 plus k over 4 has to equal 1. I'm going to multiply through by 12 here. I'll get 12k plus 6k plus 4k plus 3k equals 12. So add up all of my k's. So I've got 25k equals 12. So k must be 12 over 25. One question for you to try. See if you can give it a go. So again, we've got the random variable x, and the probability that x takes the value x is kx this time, and x can be 1, 2, or 3. So we've got 1, 2, and 3, and it's k times x. So k times 1, k times 2, and k times 3. So all the probabilities have to add up to 1. So we've got 6k has to add up to 1. K plus 2k plus 3k is 6k. So k is 1/6. And another question. So this time the probability that x equals x is kx for 1 and 2, for the values of 1 and 2, and k times x plus 1 for the values 3 and 4. So we need to find the probability distribution. So we're going to write x, and the probability x equals x. So we can have 1, 2, 3, and 4. So for 1 and 2, it's k times x. So k times 1 and k times 2. But for 3 and 4, it's k times x plus 1. So when x is 3, k times 3 plus 1 is 4k. And when x is 4, k times 4 plus 1 is 5k. We can work out the value of k, because if we add these up, we get 12k. So 12k has to equal 1. So k is 1/12. And we can even change these probabilities to 1/12, 2/12, 4/12, and 5/12. And we can see if we add them all up, we get 1. Find the probability for part B that x is greater than 2. So if it's greater than 2, it can't include 2, so it can only be 3 or 4. So it's 4/12 plus 5/12, which is 9/12, or we could simplify it to 3/4, but I'll leave it as 9/12. Find the probability that x is bigger than 1 and less than or equal to 3. So we can only have 2 or 3. So 2/12 plus 4/12, that's 6/12, or 1/2. One question for you to try, see if you can give it a go. So we're going to find the probability distribution of x. So we can get 1, 2, 3, or 4 again. So for 1, it's k times x, which is k times 1. For 2, it's k times x minus 1, which is again k times 1, so k. For 3, it's k times x, so 3k. And for 4, k times x minus 1, so 3k again. So all of the probabilities have to add up to 1. K plus 3k plus 3k is 8k. So 8k is 1. K is 1/8. So we've got 1/8, 1/8, 3/8, and 3/8. Find the probability that x is greater than 2. So it can be 3 or 4. 3/8 plus 3/8 is 6/8, or 3/4. And the probability that x is bigger than or equal to 2, but less than 4, so it can be 2 or 3, which is 4/8, or 1/2.